Namaskar, I am Dr. Joseph T Noony, and I will be using this opportunity to talk to you about the history of Indian mathematics, the short history actually, from Baudhayana till Bhaskara. The history of mathematics is so interesting to learn because it is long. It's a story that spanned out over 4,000 years. It's so natural. We find the development going from the very basic, the most rudimentary discoveries. We see a slow progress that painstakingly pursues over centuries and millennia until it reached the modern and medieval times. Going back in time, we can find that the earliest mathematical discoveries, the earliest evidence of Indians pursuing mathematics in the oldest texts of India, the Vedas themselves. How do we look at the history of mathematics? One way to do it is that people pursued mathematics for the sake of mathematics. But that is very difficult to imagine. Why would a primitive people who had no use for mathematics spend so much effort and resources trying to figure out math? The other way to look at it is that mathematics emerged out of a very utilitarian approach, out of a very real need, a practical use for it that had arisen, that had necessitated the emergence of math. Yes, indeed. In the Vedas, we find the earliest mathematicians of India struggling with the construction of complicated fire altars. They had dedicated texts written for this very purpose, the sutras, the Sulba Sutras. In them, we find the earliest mathematician, Baudhayana, describing some of the earliest results of mathematics, starting with what is popularly known as the Pythagorean theorem, which should rightfully be called the Baudhayana theorem. He not only states it, but one of his successors, all of his successors, give proof for the such theorem. This is not the only thing found in the Sulba Sutras. We find them quite amazingly dealing with irrational numbers at such an early stage of history. Now, before we proceed, we need to establish that this sutra literature is not, like the Western Indologists have successfully tried to peddle, a creation of the first millennium BC. Do we have evidence that they could actually be older? Yes, we do. We find that the mathematics described in the Sulba Sutra is also found in the slightly older text, the Brahmanas. And that is only one evidence. The second evidence which we could point out is that a method described in one of the younger sutras, the Katyayana Sulba Sutras, for determining the direction, the east-west alignment, which is believed to have been used in many Harappan constructions, is found described in the Katyayana Sutras. Now, we have a recorded evidence of this method where we use the shadow made by a rod which is tracked, and then we use another rod tied to this rod to make a circle, and the line where these two circles intersect is the east-west line, and a line perpendicular to this would give you the north-south direction. We find literary evidence of this method in the sutra literature, and we find this literary evidence archaeologically validated in the Harappan settlements. Now, both of this could be said to be proof that the Sulba Sutra literature is actually older than the earliest date of 800 BC given to them by scholars such as Pingree. The problem is Pingree tried to use this flimsy dating as proof of a transmission of mathematics from Babylonia to India. In Lothal, in Gujarat, we actually discovered an ivory scale which has the oldest, the smallest decimal graduation found anywhere in that era. So some scholars have also found that this measure, which is around 1.77 millimeters, 10 of them would amount to the measure called angula, described in various Vedic texts, including the Arthashastra and the Shatapatha. Then, all of us have used protractors. We have seen that a protractor is 360 degrees. Why? Why does a protractor have 360 degrees? Why not some other number? Why not 180? Why not 720? Why is it 360 and where did it come from? The answer to this lies in some of the Vedic verses, such as those by Durgat Tamas, where he imagines a circle with 360 spokes placed in the sky. Now this, why is it that he imagines a circle of 360 in the sky? The answer to this is also found in the Vedic text, where we find references to an early calendar, probably the earliest solar calendar ever attempted by man anywhere on earth. This early calendar had 360 days. It was still a solar calendar, but it was the earliest calendrical attempt in the recorded past. So this calendar was called the Savana year. It had 360 days as the sacrificial calendar. It is from this we can imagine that the circle of 360 degrees emerged. We also find half degrees mentioned in various mathematical texts, and the words like bhagas and amshas used. Now, the point that many Western historians make is that trigonometry emerged in Greece and Babylon, and they were somehow imported into India. But for that, we would first have to establish that the Babylonians did math earlier than Indians. And secondly, we would have to establish that there was contact between Babylonians and Indians. So, questioning the basic premises made by the Westerners, where they date all Indian texts later than 1500 BC, putting that into question. And secondly, looking for some evidence of contact between them, we find that Indic tribes who spoke Sanskrit, tribes who worship Vedic gods, such tribes do appear in the Middle East in the second millennium BC, beginning at the earliest around 17th century BC. Actual Sanskrit-speaking tribes arrived in the Middle East. The Middle East, mind you, is or better known as Mesopotamia, is composed of many nations: Assyria, Babylon. There was the Hittites, who were also Indo-Europeans. There were a lot of city-states, which together is known as Mesopotamia. But do we have evidence that someone from the Middle East came to India? No. The only evidence we have is that people from India, in the supposed time that the Sutra and the Brahmana literature were being composed, actually went to the Middle East. That in Lothal, a trading city which had a naval dock, would have invented the decimal system for a practical use of trade. And we find that the Vedic people, for the purpose of improving their calendar, of developing a calendar for a very practical use of predicting the monsoon on which agriculture would most certainly have depended, as it does today. So they invented the very foundation of trigonometry and geometry. The circle of 360 degrees was invented for a practical use. And thirdly, we find that the Sulba Sutras, which contain the earliest discoveries in geometry, was invented again for a very practical reason, that is, construction of fire altars. So in India, as I conclude this first half of my speech, in India and India alone do we find this evolution of a need a very practical need for math giving rise to high math, giving rise to math. This perfectly natural and utilitarian evolution of mathematics is found in no other culture. And mind you, it's not only natural, it is also very long. It took 4 millennia to achieve what India did in the coming centuries. Moving on, we find that the calendrical traditions continue to be improved, but mathematics took some time. For the next 2 millennia, until the time of the Jaina mathematicians, starting in the 5th century BC, we hit a kind of a roadblock. We do not find many discoveries coming up. The Jaina mathematicians made some contributions, but for sake of brevity, I'm not going deep into them. I'm jumping straight to the next big thing that happened in India. It was the Bakhshali manuscript, a highly degraded birch bark, a bunch of birch bark manuscripts were discovered in what is now Pakistan. They are now preserved and studied in the UK. What is so significant about this Bakhshali manuscript? Until its discovery, it was believed mainly by and propagated mainly by scholars in the West that the Greek Diophantus was the father of algebra. Diophantus lived in the 3rd century AD, it is believed. What did Diophantus do? He studied linear equations, the Diophantine equations, which only sought whole number or integer results. So Diophantus has long been held to be the father of algebra. And recently, the Bakhshali manuscript was dated to actually belong to the 3rd century AD. The 3rd century AD, I mean almost the same time as Diophantus, but it contains even more significant results than what Diophantus is said to have discovered. So no longer can it be held, and people have actually tried to show that Indians like the author of the Surya Siddhanta and Aryabhatta may have been influenced by Diophantine algebra coming from Greece. Such a theory can no longer hold. We find that Bakhshali manuscript, which contains the actual solution to linear equations, the solution to the quadratic equations which contains equations with 5 unknowns, it contains progressions, it contains quadratic indeterminate equations. In fact, one of the translators of this manuscripts in the UK, GRK, he actually tried to date the text to the 12th century AD, long back. Why? Because it would be easy to show that Greek and Arab mathematicians had influenced it. So in India, we find that at least from the 2nd century AD, algebra was flourishing here. Algebra is without a doubt an Indian invention, and it is not curtailed by the insufficiency of the Greek numerals, which simply could not handle fractions. And for that very reason, we were able to go much beyond the Diophantine equations. So that is algebra, which continued to be developed over the centuries. And then, for sake of brevity, instead of going through each and every mathematician who thrived in North India for the next 1,000 years, I will be talking about one major city, the most important center of mathematics in history, in Indian history. It was the city of Ujjain. In Ujjain was like a magnet that attracted all the bright minds from all over the country for centuries. It is said that Brahmagupta came from Rajasthan, Aryabhatta, wherever he came from. Some say there's a consensus that he may have come from Bihar, or at least done his early education there. He may have come from Bihar. It is said that Vadheshwara came from Kashmir. It is said that Bhaskara the first came from Maharashtra and Bhaskara the second came from Karnataka. So what we find is this important center for mathematics and astronomy, attracting the best minds of the country for centuries. People just gathered there. It was like the IIT of ancient India. Only the best people worked there. Now, what did Ujjain give the world? Ujjain gives us the very foundation of modern trigonometry. The author of the Surya Siddhanta very probably lived and worked in Ujjain. For the first time, the sine and the cosine were described in the Surya Siddhanta. The very first trigonometric tables, were given by Aryabhatta and Varahamihira, as well as very many trigonometric identities. They were all done in Ujjain. Spherical trigonometry, where, as given in the Goladhyaya of Bhaskara II. The first, the observation, the all crucial observation of the heliocentric periods of the planets as given in the Aryabhatiya. Aryabhatta observed them from Ujjain. The explicit declaration that the earth is rotating on its axis. Aryabhatta figured that out sitting somewhere in Ujjain. The first differential equation in history found by Aryabhatta. It was found here, it was found there in Ujjain. The old question of why people don't fall off the earth, it was asked again in Ujjain. At this point, I would like to point out to a very interesting story given in the Leelavati of Bhaskara II. The Buddhists of Bhaskara's time, they had the belief that all the planets were falling freely in space. The Buddhist philosophers and the Buddhist scientists who may have been sitting in Nalanda at that time, they held the view that all the planets were falling freely in space. To which Bhaskara II replies, no, the planets are not falling freely in space. In fact, they are all held in their orbits because of the force of attraction, Gurutva Akarshan. The planets are all stuck to their orbits because of a force of attraction, Gurutva. This statement was made by Bhaskara II in Ujjain. Again, the principles of latitude and longitude determination for the purpose of timekeeping, for the purpose of navigation, all of this was worked out by the mathematicians of Ujjain, most prominently by Bhaskara II. So in short, it is not possible to describe everything that was done by all these great super minds over a period of 1,000 years. It is not possible. I just described the most important ones. But sadly, the history of Avanti, of Ujjain, the Avanti Observatory, as we may fondly remember it, ended around 1233 AD CE when Sultan Iltutmish of Delhi invaded and destroyed the city and the university. How from the very basic need of using math to solve the very real problems of life as faced by the early Vedic people, gradually, persistently, and quite naturally evolved into the highest culminations of astronomical and mathematical discoveries in medieval India. The story does not end there. The story moves on to the south of India, in Kerala, where in the kingdom of Kochi sat a young man who did not have access to a great observatory. He did not have access to a great library. He did not have much resources. He was not part of a great institution like most of the mathematicians before him had enjoyed. And that is the story of Madhava of Sangamagrama, which would take a whole new lecture by itself. But for now, we have seen the history of Indian mathematics, starting with Baudhayana and ending with Bhaskara II. And the focus of mathematics now shifts from the north of India to the south in the second part of the story. So, to conclude, we have seen the very practical origins of Indian mathematics in the Vedic era. We have touched upon the all-important topic of dating the Sulba Sutra literature. We have seen how we do have quite strong evidences to show that the Sutra mathematics is in fact contemporary to the Harappan era. We know that we have fire altars in Harappan cities like Kalibangan and Lothal. We have also seen how the direction determining technique found in the Sutra literature is believed to have been used in Harappa. We have seen how the units of measurements that we find in the Sutra and the Brahmana literature, they also seem to have been used in the Harappan civilization. So taking all of this together, we can now conclude that Indian mathematics, as evidenced in Harappan archaeology as well as the Vedic literature, they're both one and the same. Then we have also seen how there is a continuity in Indian mathematical tradition, though we have not been able to go into the details of each and every discovery that were made over the period of 4 millenniums. We have touched upon the most important of them, the most important ones of them. Then we have also seen how based in the university, the observatory of Avanti, a long line of mathematicians contributed an immense number of results, discoveries, and theories to both mathematics and astronomy. So on the whole, as I conclude, I can say that the first part of the history of Indian mathematics played out in North India, starting probably with the first mathematician recorded, Baudhayana, and ending with the 12th century genius Bhaskara II. This first part played out in North India, but that would not be the end of Indian science and mathematics. It would continue in South India, especially in Kerala, in the kingdom of Cochin, by the famous Madhava of Sangamagrama and the school he founded, his long line of disciples, his Guru Shishya Parampara. But that would be a speech for another day. Thank you.